Hello, this is on arc lengths, which is the subsequent topic from circumference, okay? So let me review everything again. Circumference is basically the perimeter of a circle. Basically, when you draw a circle, the line that you draw is called the circumference, right? When you're drawing a circle, this is called the circumference. Now you need to know that the radius is half of a diameter. A diameter is a line through the middle point of the circle. A radius is half of that. Now there are two formulas that you can make use of. Pi times diameter is circumference, and 2 pi r is circumference as well. I usually go for 2 pi r. So if there's a diameter, I'm just going to divide it by 2 and then get an r out of it and put it into the equation. So instead of memorizing 2, I have 1 only. But both are okay. Now next is an arc length. An arc length is basically part of a circumference. So we have to make use of ratio. Ratio of what? Ratio of the angle. So the angle can be, let's say, if you're doing a semicircle, you're going to multiply it with 1/2, which is basically the same as divided by 2. Okay? If you're finding a semicircle, let's say. Now what's happening behind that is the angle is 180 degrees, which is half of a full circle. So you're going to do 180 degrees divided by the whole circle, 360 degrees. A whole circle is always 360. And if you cut this or simplify this, you get 1/2. So that's what's happening behind that. All right, so let's start with some questions. Now you've got to be careful which arc length you're finding. So for example, B can be tricky, and I'll explain a bit. 1A. Okay, so 1A is an arc length with an angle within the sector. So we can directly use the formula. 2 pi radius 16 times a ratio of angles, which is 63 degrees over 360. 360 is the total angle, so this is the ratio. Basically 63 out of 360 degrees. What's the arc length gonna be? So if you calculate this, 2 times pi times 16 times 63 divided by 360 is 17.6 cm, 3SF. Now for question B, you will notice that the angle is not on the same side as the arc length, right? So we have to find this one first. Basically, we call it angle AOB equals to. Now the other side of that is basically 360 degrees, a whole circle, minus 244 degrees. So 360 minus 244 is 116, 116 degrees. So this angle here is 116 degrees. Now to find the arc length, we can also call an arc length AB with an arc around it. This is equals to 2 pi r, 2 pi 7 times 7, times the angle that you have, 116 degrees over 360 degrees. So you gotta be careful with these kind of questions where they give you the other side of the angle that you need. So you have to find the correct angle first. 2 times pi times 7 times 116 divided by 360 is 14.2 cm, oh not cm, meters, 3SF. Now moving on to, these are okay. Moving on to a more complicated question. So over here, they gave you the arc length, which is 51 mm. You gotta find the angle this time. So again, we're gonna construct the arc length equation formula, basically. 2 times pi times the radius is there, so we just put it as 18. Times an angle, ratio, angle over 360 degrees. So we don't have the angle, we label it as theta. Theta or theta. I think I call it theta. Theta is, no, I think it was theta. Theta? I forgot already. Theta is the angle that we're trying to find, and the arc length is provided for you, 51 mm. So this is quite complicated because you have to move things around. You need to make theta the subject. So it's gonna be 51 divided by 2 times pi times 18. 360 is at the bottom of the fraction, so it's going to be times on the right side, 360 degrees on the top. So let's solve this. 51 times 360 divided by 2 divided by pi divided by 18. You gotta be careful with your calculator. So theta is 122 degrees. 3 significant figure. For number 2, we need to find radius this time. The angle is given, but the radius is not. So again, we're going the same procedure. 2 pi the radius. Radius is not given, so we have it as r. The angle is provided for you, 96 degrees over 360 degrees equals to an arc length provided, 8 pi. So make r the subject, you would have 8 pi divided by 2 pi. You can calculate this first if you want to. So let's say I'm gonna calculate the numbers. 2 times 96 divided by 360 is gonna give me a fraction, so let's see. 8 over 15. So this is gonna be pi r 8 over 15, right? So it's up to you if you wanna do this or not. R equals to 8 pi over pi. 15 goes on the top, 8 goes at the bottom. Now you calculate this, you can actually cut 8 and pi. What's left is 15. So directly you have 15 as an answer. You don't put cm because cm is written down for you next to r already. Okay, so this is another type of question. Again, we're just using the same formula. So let's say you want to find arc length, then everything else is given on the left side, you're finding this number here. If you want to find angle, like in this question, well, the angle is going to have an unknown, but you have a number over here on the right side. So you just make the angle the subject. If you're finding radius, then you're going to make radius the unknown, and the others should have a number, right? So it's just the same equation formula. You're just plugging in the numbers correctly. I'm going to do one difficult question. Maybe number 5. Let's do number 5. Now, number 5, usually the difficult questions goes like this. Find the perimeter of the region ABCD, right? So perimeter of the region ABCD means ABCD is this part over here. Yeah, that's ABCD. So you have to divide it into sections. This will be a blue color, and I'll label this as a green color. The two lengths over there can be in red. Now you can directly calculate the perimeter all at once, which I love doing, and you guys probably not. So you guys might get overwhelmed. Let's start with the simple one, the green one. So the green one is an arc length. The angle is given. It's over here, 130 degrees. Now 130 degrees belongs for the green one and the blue one, okay? They're also 130 degrees. This one here is also 130 degrees. So let me handle the green one now. So green one's an arc length, so we're gonna go for 2 pi, a radius. The radius of that arc length is 6 over here, times 130 degrees over 360 degrees. That's it. So that's the arc length equation. Now we're gonna add the blue one to it. So 2 pi r. The radius is not the same because the green one has a radius of 6, while the blue one has a longer radius over here. So we gotta figure that out. It's 21 actually. 21. They're same angle, so 130 degrees over 360 degrees. Now you have to add these two red lines here. So we need to figure that out. Plus, if this is 6, this whole thing is 21, so it must be 21 minus 6, right? 21 minus 6, and since there are 2 of it, times 2. Now you can calculate everything all at once, but you gotta be careful in putting into the calculator. 2 pi times 6 times 130 divided by 360 plus 2 times pi times 21 times 130 divided by 360 plus bracket 21 minus 6 times 2. Whatever you write, you have to put it exactly the same in your calculator, including the brackets. 91.3 is the answer for this question, CM 3SF. All right, there are some questions that are more difficult, like this one over here, maybe. Our ABs are arc lengths with it will be 52. If the perimeter of the shaded region is 70, okay, this one's difficult. So perimeter is 70, including this one and this one. We don't have the radius, so basically what I'm gonna do is 2 pi r times 52 over 360. That's gonna be this part here, plus the 2 radius, plus radius, plus radius. These are 2 radius, right? Is equals to 70. So I'm just gonna solve r this way. I'm gonna combine all the r into a single one, and then you can solve r. All right, so that's it for this video. It's really complicated at first, but once you keep on going in the chapter, you're gonna get used to it, and hopefully you get better marks afterwards. Okay, bye. Good luck for homework.